Recording.
signature. We need to check them.
Okay, so today probably not gonna be the last day, unfortunately, but we need to do lookups. We need to do lookups. Again, more lookups. So inside the compiler there's a to-do somewhere, a debug actually somewhere, that says what we need to do.
This one, right?
Yeah. Um. So what's the plan? What's the plan?
What is the plan? Let's see. This is a module which actually, first of all, let's look at the types here. So a comp time module of compiled module.
Actually, this is kind of annoying now that I think about it, because it would be very nice that we should cache this behavior, right? So after you found the signature for this module, you should stick them together forever, because you may have to do more lookups later anyway, and you don't have to keep redoing this operation every time.
Mm, that doesn't quite work because a module may actually be ascribed to different signatures in different contexts.
Yeah, sure, but in the current context, the first time we bound it, we made them together, like the first time we make a relationship between a module and a signature, we should keep it that way until otherwise, right?
Yeah, no, that's not quite gonna work because oh, hello, Ace.
Hello.
Because when we get to functors, the same module may appear under different signatures in different contexts.
No, yeah, but that's fine. I'm still not getting it. I'm not saying we should glue them together forever. I'm just saying that they should be glued until they should, until we can, that makes sense, and then we can unglue them later. Doesn't really, that's not a problem. My problem is that
Mm,
we are trying to determine if a particular predicate is part of a module. Every time you use the module's predicate, you're gonna have to check the signature as well, right? Because it doesn't really matter if the predicate is there, but the signature is hiding it, right?
well, there is the option of just when a signature is ascribed to the module, we can just strip away because we need to check that the module satisfies the signature, right? We could at the same time just strip away anything that the signature says shouldn't be there.
Yeah, we already had this discussion before about like, should we just uh, implement it in a way that is not just not there, but then the error message is gonna suck, right? We had this discussion before. It was exactly this question. Are we gonna are we gonna like cut the module up to the parts that are only visible according to the signature, and then we're gonna
Mm,
use that throughout, or are we're gonna carry both of them so we can have more context for reporting?
hmm. You know, there's actually a third option here. We could do this. Um, and then when we match a module to a signature, assuming the module satisfies the signature, Instead of just removing the things that don't match, we move them to this hidden entry. And we can use this for error reporting later.
Um, that is okay, actually. I was kind of thinking of having a func label optionally in here because again, I don't want us to keep redoing this every time. So we would like to like save something about the signature that we already are aware. This is it, right? This is also the same thing. We are aware of the predicates slash directives that the module is being filtered based on the signature, and we're just moving them around to the hidden portion, if that's the case. That sounds really reasonable to me.
I'm pretty sure this is gonna break stuff though, so let's see what
When
we
are we
need to
gonna do
fix.
that though?
When we say that a module must satisfy a signature. When we check the signature, if the module has everything that the signature demands, we just move everything else to hidden.
Uh, okay, this needs to be considered in the lookup functions then.
No, that's the beauty of it, because the lookups only know about these things. They don't know about hidden. But then if we fail to find something, we can check the hidden when we report the error, you see?
No, but that's exactly the problem. Sometimes you're gonna have to do lookups on the hidden anyway, because you lookups from the perspective of inside of the module should behave as they currently are, which is everything is
No, no, no,
available.
no, no. Lemus, there are two steps. First, you build the module, and nothing will be hidden. And then after that, you match the module to a signature. You construct a new module that references the things in the original module, but some of them may be moved around.
Oh, you're not gonna like replace it. You're gonna like double it up, but do the move to the hidden.
Yes,
That
why would I do
sounds
anything else?
because that sounds wasteful, right?
This is immutable, Lemus. Structural sharing for the win.
It's still wasteful, right?
It
Or
isn't.
no, you gotta convince me that it isn't then. You have a record there that has these three fields, and instead of doing a replace, you are adding a new version.
Like, the point is that this map and this map here, right? The full version when the and the in the small version from after you match the signature, they will share structure because these are immutable, you see?
I still don't see the benefit of having both at the same time. I would only rather have one.
Because you may still have a reference that hasn't been ascribed to the signature laying around, right?
Uh, you may still have a reference laying around and
Like,
not
okay, here's an
matching the
example.
signature.
Here's an example. Let's go to AST real quick. Like, I could say, like I have expert here, right? Expert, which doesn't have a signature assigned to it, right?
Uh huh.
I could go and do this. Module abstract expert of type expert equals expert. Like this is totally valid.
Ah, wait. Okay, that's valid, but proceed. Continue.
Yeah, see, and in this case, if I try to access something through this abstract expert, this has the signature, which means you don't have access to everything.
Yeah.
But expert is still in scope, so you could use that, you see? You need both available.
Ah, okay, I see. So the reason you have multiple versions is because you may be reusing the same signature. This is a
Well, the
very
same.
specific use case, though. You are using a different signature but the same implementation.
It isn't actually, because like
We
right
haven't
here is
done
an
this so
example.
far in this project in OCaml, in the OCaml program.
But we have. What do you think this does?
Um, okay, this is not exact. Okay, so we are talking about different things. I'm talking about what happens after the equals on line 100, right? You were talking about the signatures thing. I'm understanding the signature part. But this case that you're mentioning as an example is you have a module that is restricted by a signature, and it just so happens to have the same implementation of another module.
Which is also the case down here.
Well, but this is because this is using functors, not because of the example up there, which we don't have
Well,
functors yet, right?
but like a functor is taking this expert here. It's matching it with the signature because you must have a signature in a parameter of a functor, right? But the
No,
expert
I
is
think
still
I'm
available
following though.
without the signature outside of it, you see?
Yeah, no, I think I'm following. You are like future proofing the thing, already thinking on how we're gonna get functors done later.
Yeah.
And the way to do that is by using the sharing structure thing. Okay, that makes sense, but that still has nothing to do with what I was saying before. So, uh, do you agree that the functions that are not um, exported by the signature should still be available from the perspective of inside of the module?
Well, yes, but when the module is initially constructed, it has no signature, so everything will be here.
A module when it's initially constructed. I have a question.
Yeah.
You can in OCaml make a module with a signature, like in a single shot, right? Like an inlined signature or whatever.
Well, yes,
Do
you can
that.
do something like module, whatever, has the signature expert equals struct. Yeah, you can totally do something like this.
Exactly. So the module is being created with a signature. It's not a two-step process. That's kind of what I
It
mean.
is Lemos a two-step process because this is actually independent from the left-hand side of this.
It's independent. I think I disagree fundamentally because the left side is explicitly dictating what the right side needs to have.
No, 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 no. This is an expression, okay? This is a module expression, right?
Sure.
This is a binding, okay?
Also, sure. I don't know how that relates, but sure.
You can attach a signature to the binding, but that's different from like that's not changing the expression.
No, that is restricting the expression.
No, no, no. This is the expression is what it is, and then when you try to bind it to whatever, then it tries to get matched to the signature after the structure already exists.
No, sure, but what is the purpose of having this middle level ground understanding of like, okay, I actually have the expression done, but it's not gonna compile anyway because it doesn't match the left side signature?
No, it's not that. Okay, this lets you avoid having to deal with the problem you were bringing up of okay, this needs to be visible inside of the module but not outside of it.
Ah, okay, I see what you're saying. We're saying that if you divide and conquer the problem by saying that the right side is initially independent, then you just treat it as it is. It doesn't have to do like special case. And then when you add the left side later, it only matters from the colors of this guy and not this guy by itself. Okay,
Um,
okay. So
yeah.
basically, yeah, I think I see what you're saying. So this
Uh,
means that yeah, I don't know what this means in terms of the lookup functions yet, but I think I understand what you're saying. Um, so the module is going to be independent, so the lookups work normally, even the ones that are not being exposed. But whoever calls this module needs to take into consideration the signature. Cool.
yeah, yeah. So basically, um, Constructing a module that has an explicit signature is just constructing the module without the signature and then matching it with the signature afterwards when you bind it to the name,
Mm-hmm.
basically.
Okay, so let's go through the compilation errors. And we have to think a little bit about where we're gonna do this.
This doesn't quite work actually. It doesn't quite
We
work.
don't know what to put in there, right?
No, the problem is that this can't just be this because there's no base case for the
Yeah, we don't know what to
recursion.
put in there. So what about making this an option? And then the base case is none.
Yeah, that works.
Yeah. I just put
Uh,
option at the end of the line. That's it. Okay, so after we have hidden, what do? We At the moment that we bind, we make the connection, the mapping between a signature and the module. That's the time that we need to do the moves from hidden. Oh no, the lookup functions are actually, they need to take care of they need to be aware of this, because if they have something in hidden, it should be using that in the lookup and not the inner, not the exposed one, right? Are you gonna put hidden the ones that are implicit or the ones that we're gonna expose? The ones that are
no,
implicit, right?
yeah, no, the ones that are hidden will be inside of hidden. That's why it's called that.
Okay, so the lookup functions can stay exactly the same. We just do the migration of what's hidden, what's not, and we're done.
Um, okay, that builds.
Okay, so now let's go to the compilation of modules and see which places are the places that we need to do something about it. So in the case of module 1, which means that we don't have a signature, my understanding is that if that's true, we do nothing because everything
We
is
just keep,
exposed by default.
yeah, we just keep doing as we are.
But if you have module 2 case, which is either a named signature or an inline signature, then you need to do something about it.
Actually, module 1 can also have a named signature, can have an inline signature actually.
Um, module 1 can have an inline signature.
Yeah,
Can
remember,
it?
because we're gonna change the syntax to allow two bodies, and the inline signature will be the first body actually, if we have two.
Okay,
We
but
just
then we
haven't
should
gotten
do
around. Yeah,
we
we
should
haven't
do this
gotten
right
around
now
to
though.
it yet, but that's the plan.
Okay, but that with a new parser that seems like a no deal at all, no big deal, right?
Yeah, it's fairly easy to do.
Right, just go to the directives and add a list there. Yeah, we should probably future-proof ourselves and just do list instead of a tuple. Maybe in the future we're gonna have multiple bodies, not only two, for a particular directive. Um,
Okay, so a directive,
yeah, it's
it's
essentially
a
making
functor
449 all the way to 454 a list of. All of that. All of that is a list of.
left curly
No,
brace, top
not
level,
list
we
of, right? Because
capture.
we have better partial. So it's a star. No, plus. This is plus for sure. Yeah, just wrap everything from 449 all the way to 55454 in a plus, no? And that's it.
Yeah, let me just. Yeah, this doesn't quite work because I have a lambda in the middle of the way here.
What do you mean? Can't you just put parentheses in there?
I mean, we can, but we are using this body down here.
No, this entire thing is a gigantic parenthesis, man.
Mm,
Ah, I see what you're saying. It's because 454 is actually the end result, not the actual parsing of the. You're already done with the curly braces at that point. That's what you're saying.
I think there's a way to deal with it though. If we do.
Isn't it 449 all the way immediately before the period in 452? And that's it?
Yeah, we just need to be careful about not discarding the body when we parse the right curly brace. Okay, so this is going to be a star.
Probably plus, because star is 0 or more, right? Needs to be at least 1 or more.
I mean, we can have a directive with no body.
What would that be? Import, right? No,
An
but
import wouldn't. Well, we wouldn't use an import, but
no, we would. We still need a directive to do the module renaming, right? Like Erlang.
mm,
Well, Erlang doesn't have it, but there is in Orlando. Orlando, no. There is a way that you can do that. Oh, in that
okay,
case,
so
it can be a
star.
star.
Um,
Yeah,
Hello, Mageta.
hello, Mageta.
we have a whole standard library bigger than OCaml's now. Mhm.
Not quite there yet.
2 more sessions and we're gonna get there.
I was expecting today to be the last one, but I have a feeling that serialization is not gonna happen today.
Uh, um,
Yeah, don't forget to not put the period there, Marin.
Yeah, no, I'm just going to grab this. And then we return the body. And then,
Yeah, you should be able to remove all of that into the period parsing.
bodies, and then we don't care about this. We parse a period.
We don't care. Then we skip a bunch of white spaces and comments. Then we return, and yeah, and we just need to now have bodies in for 5.8. Yeah, but this is
Yeah,
not
and
gonna
this
fly
can
because yeah, exactly.
return bat finger tree t.
Okay, but now the parser clause is kind of fucked up. Ah, I know why. It's because of the line. Yeah, that one. 427. This is fucked because the directive that we have, the directive function, that one, we need to change the type here as well, 104.
Mm, t list bat
Oh,
finger
we're gonna
tree
actually
t.
mix that up here. So now we have lists and bad finger trees mixed up. I don't think we should do that. That's gonna make the handling of this data structure inconvenient.
I guess we can just make a list.
Well, there is an issue. that I haven't written because I forgot to like rewrite everything to use finger trees anyway.
Mm,
88, all the way up there. Oh no, this is a
that's in the.
preprocessor, so the parser is fine. That was fast.
Yeah, no, it's very nice when things just compose properly.
Okay, but we probably have more problems though. So 88. Ah, this needs the double map now.
Does anybody want to see me presenting the high talk later?
Yes. After we're done here, I would like to see that.
All right.
Is this gonna
Man, I
work,
really
buddy?
hope I get better. Uh, Trust
Mm,
Marinlams. He
Oh, I
knows
do
everything.
trust him, but
Marinho knows what is best.
this
yeah, this is not
expression
quite
has
right.
this, but it is expression of expected of type that.
Mm, maybe it's just easier to put the mapping, the nested mapping inside of this.
Well, I don't know what's the problem with the previous approach. That should compose. I don't know what happened there. Yeah, the problem is a double list, but what are we doing wrong here?
This is
Oh,
a
I know
list
what we are
list.
doing wrong. I think we need to wrap this filter map with a normal map, not a filter map. You did double filter maps, right? I think
That
it's the
doesn't
other way
quite work
around. I think it's the other way around.
the
It's
other way
a
around.
yeah, filter map inside and map out, on the outside.
Okay, this is going to filter map everything.
Seems to be happy.
Do we want to remove the empty ones? I don't think so, right?
Do you want to remove the empty ones? We already were doing that, right?
No, I mean around the, I mean the outer list. I
But
don't think so, right?
yeah, but the outer list we are not removing anybody.
Mm,
Yeah, that's a different error.
oh, well,
Uh, this is in a pet. Oh no, this is not in a pattern matching, so never mind. So what's the problem? This expression has type this, but an expression is expected of type this. This is due to the. I know what this is. Go to AST. We forgot to change in the clause module. Only the parser clause we did the change. Same change up there. Same thing. Okay, now the compiler is fucked.
Hmm. And it's still stuck on the conversation we had yesterday. I will talk about that later.
That is fine. We can talk about that later as well. Okay, what is this? Yeah. Okay, but these will probably create non-exhaustive cases that we should properly report errors to the user. So
when in
this is in compile
when
signature?
inline signature is non-empty. Oh, right, because this is when you are defining a module inside of a signature. So this is not
Yeah.
a real module. This is just a. It's just a member of a signature, I guess.
Yeah, but this creates another situation, right? Because now, if you are a module inside a signature, you can have an inline signature now, right? That was not possible before, but now it is.
If you are a module inside a signature, yeah, you can actually.
Yeah, so what does this mean? This means... No, actually this is fine, right? Because in a signature case, the only body that a module can have is the signature. It cannot have implementation. So this should be an error actually. So if you try to have multiple bodies with a module inside a signature, we should report that as an error.
Mm,
So it's probably
okay,
going to line
we're kind of
473, but I think we
yeah.
could do better though. Like this is doing multiple errors at once now, right?
Mm, let me think for a second. This is module 1 with a signature.
Yeah, which is completely understandable. This is the hack, remember, that we did? Like we noticed that we needed to use a list before, but then on the signature case, the AST was only holding one, and we said to ourselves, okay, let's just do this as the signature on 458, and then we had it, right? But what happens? What should we report if you have a module one with multiple curly braces there? You see?
Right, you are right.
Love when Marinho does the ASMR.
Uh, I guess we can just keep this zero as it is and see if that's problematic. We can do some particular cases later. Yeah, now it's line 500 all the way down there. So what is this? This is signature.
All right, this can only have um, oops, this can only have one body actually.
What is this? Is this
This
still
is
compilation of
this compile signature, and this is a nested signature inside of a signature.
what's the error if that's the case? If we have a list with more than one, what's gonna be the error there? Directives and signatures cannot be qualified.
Yeah, this
Yeah,
is
that's
definitely
bad.
wrong.
That's very bad. Well, we should make a particular case if the list is not empty though.
Yeah, this is basically this, but um,
Yeah, pretty much. Yeah, you can also remove the unused names here, the unused bindings.
let's see. This
Wow.
is yeah, this is matching one element, and this is matching well more than one because one is already matched.
Yeah, so the error should say something like
I guess this is
sign.
more explicit, and then we don't need all of these bindings, right?
Yeah, all these names are. You can get rid of them. Oh, actually no. The name is useful because we can say that. Oh, we're gonna be pointing at it. Doesn't matter. Then the location already has. Signatures can only must have at most one body. Yeah. What's the next error? Compiler. Okay, 738. Go there. Ooh, compilation of a clause. Interesting. This is just a type error in the type of compile directive.
Hmm.
You just need to change the type of the compile directive function, and then that should be it. It's probably now expecting only one body. We need to send a list over there. Yeah, it's the third argument. This should be a list. Yeah. Now go back to the original problem.
Hmm.
Ah, I see what's going on. We unwrapped it, but now we are saying that the top level function expects the wrapped version. Just put brackets around it or do an S in 489. Yeah, this also works. Next compiler. Compile step also needs to be changed. Because now this accepts a list of a list.
Actually, no, this doesn't make sense to put a list here.
Yeah, this is translating to the being forms, so we shouldn't do that in this case. So what's wrong up there? Let's go back. What is this doing?
It takes a body, this is compiling a module.
Uh-huh. Where is body coming from?
Probably from up there. Yeah.
Ah, I see the problem. Um, okay, so my suggestion is the following. Put body in 55 true in the tuple, and we need to match how many bodies we have, because we have to change what we're gonna do depending on how many bodies we have, right?
Right.
So this case is the singleton case, right? So you can just do like open close brackets body, and that's it. Don't forget the comma. Yeah. And now this is probably not exhaustive pattern match. Well, the pattern matching maybe also be broken. Yeah, as expected. This is also the singleton case. For now, everything is singleton. Is the compiler happy? No, there's signature as well. So signature should always have only a singleton, right? Signature 1 in this case.
That is correct, yes. Should
Yeah.
only have one.
And these are errors, so just underscores. Yeah, that's good enough. Same thing for all of those. Just put underscores. Yeah, that's gonna be useful for later, newer, later directives. Okay, save this. Let's see what the compiler says. Awesome. That was easy enough.
Uh, just one thing. Compile module. Compile module. We don't have a compile module that's separate from compile directive, I guess.
Yeah, we don't. It's a gigantic recursion scheme. I think we should commit this already, as it is.
Okay.
And then now we need to take care of the non-singleton cases. So if you have a signature, that should always be singleton, for sure. But if you have a module, then we are talking. So if you have module
Mm,
module 2 also must be a singleton. So that's interesting. Try to find
module.
module 2 because we should make an error message. Probably.
Module 2.
Yeah, module comma 2 comma yeah. I think if you have a module 2 that is not a singleton, then you're wrong, right?
Yeah, you are.
I think yeah, that's pretty much. So we should have yeah
Mm,
an error message this explaining this to the user because you gave us the name of a signature and you gave us the body, you are done. There should not be another body there.
where is lock coming from in the other app messages? Directive lock, okay.
Yeah. Okay, so this is like modules with signatures with a named signature must have only one body. Yeah. So the only case that we can have a non-singleton case is if it's module 1, right? Because if it's
Yes,
module 1,
because
there's only the name of the module, and you can either let us quote unquote derive the signature, which we're not going to do, but you can also give us an inline signature.
yeah.
That's the only case that the singleton that it doesn't necessarily need to be a singleton. That should be very easy with the apparatus that we already have, right? We already know how to compile a signature, so this is just a matter of concatenating those two functionalities now. Which kind of sucks, because this means that this implementation of the singleton case is going to be exactly the same for the non-singleton case, which probably means it should be a function. All of these match elements onwards. This should be a separate function.
Hmm.
Yeah, man, definitely. Because look at line 576. We're gonna put the check of the signature there anyway. So here's my proposal. Grab these match elements, or everything inside this parenthesis of 553, we're gonna put in a function. Then we're gonna call this function with different parameters depending if you provided a signature inlined or you are quote unquote deriving one. You see?
Yeah, I see.
Surprisingly that the
Although,
functionality is the same after that.
although there is the alternative of this could just be a recursive call in the other case.
What do you mean?
Like, if we do module
Uh,
1 um, inline signature, let's just call sig, I guess, body, it needs to be like this. Um, in that case, we can do compile directive lock. Um,
I don't think that's gonna fly though, because we need to compile the signature first.
this is F, this is body, this is compiler.
Yeah, so here's my pitch. We should grab we should do compile signature first with the inline signature, grab the compiler output of that, and then call ourselves. What do you say?
Mm, that can work, but that's backwards with the
Ah,
like
with
that's
the
gonna
strategy that you described before, yes, it is backwards. You need to compile first the module separately, and then you add the signature layer on top of it. It cannot be the way that I said. It needs to be the other way around.
yes. Also, we don't really have a way to do like an anonymous signature yet, do we?
Of course we do. It's just a curly braces, man.
No, 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 no. That's the syntactic way of doing it. But like, how do we represent that in the compiler?
Ah, our signatures are always nominal.
Mm,
Okay, here's my pitch. Given that signatures and modules share the namespace, can't we just make an artificial name that we know is going to be unique anyway? Like the module name dash sig or whatever? Ah, but I see the problem. What happens if the user in another place of the program also calls his signature, the module name that happens to be the same one as this one? and dash sig, and we're fucked. It needs to be unique in our case.
Ah, no, okay, compile signature already is anonymous. We do the name binding afterwards.
Oh, okay, awesome. If that's the case. Okay, so what do you say? We compile the body of the module first, then we grab the compiler output out of that, and then we compile, we add the signature stuff on top of it?
Hmm. Okay, let's do it like this. This is actually, oops, that's not what I meant to do. This is the signature body. Let inline sig equals compile signature. Uh, hmm. This is a bit tricky because we don't have a location associated with each body, do we?
Um, oh fuck. Okay, fuck me. We forgot about that in the parser, didn't we?
Okay, I'm
That's
gonna
so
put a
sad.
to do here and we'll get back to that in a bit. To do. Add
Uh,
locations to each body.
Yeah, but this will give us what is the. This is still missing a compiler, right? So we need to press a compiler there. And this gives us a signature with location, which in this case is the wrong location, but the to do is there, so it's fine. Then what we need to do, what we need to do,
We need to compile the module with just the body, with no signature.
yeah, but
And
there's a
then we need to grab the module name, look up the module that we just compiled, and we need to ascribe the signature to it, basically.
yeah, but there's a problem. Line 576 is expecting us to already have the signature available, but that's not true in this case.
576.
Yeah. At the moment that you go to 576, it's expecting that we already have the signature on hand to do the checks, right?
Ah, we can do this afterwards. That's not a problem, actually.
But doing it afterwards introduces a new problem because whoever is calling compile directive expecting the singleton case also needs to have this treatment.
Expecting the singleton case.
Yeah, because we are doing the recursion scheme that is matching the singleton right up there with just a single body.
Yes.
But these only work. We can do what you said on the case down there because we're not a singleton case. But what about the cases that we go directly to the singleton case? You don't
No, this
have
is a
a.
singleton. This is still a singleton case, Lemos. It's just that this has two bodies.
No, but that's what I'm saying. You can match the first K pattern match and not match the second one if you don't
Well,
want
in
an
that
inline
case,
signature.
well, yes, but what's the problem?
No, it's not a problem. We need to remember that and take that into consideration because whoever is calling compile directive may go into this situation. So the color of that also needs to be updated with this trick, with this check.
Why?
What do you mean why? For the same. Ah, it's because in the case that you are doing that, it doesn't matter, right?
Yeah, because like if you don't have a signature,
You
then you
don't care
just
about
don't
that
have
at
a
all.
signature. Yeah.
Okay, no, never mind. You're right. So just remove the 576. Remove that logger.debug, and let's just do it in here. Down here, I mean. Yeah. So, but this
Okay.
cannot be in this cannot be in tail call though. So just grab the.
Yeah. Yeah. No, I know. This returns a new compiler, right?
Most probably. Okay, and then
Okay.
now we need to do something
So
about it.
so we need to look up the module, and we know it will be there because otherwise this would have failed, right?
Remember that it's a two-step process, right? First, well, I don't know which one needs to come first or not. Maybe there's a performance advantage of choosing which one should be the first. We need to first check if whatever the signature is specifying is being fulfilled by the module implementation. And second, we need to move things to the hidden field. We can probably do both at the same time in a single fold.
In a single fold. Yeah, I'm probably just gonna do a helper function for that, to be honest.
That makes complete sense. But we should be able to do this in a single fold, I believe. We just we do the lookup, and if it's not there, it's in hidden. And if it's there, it should be kept in there. So it's fine.
Let ascribe signature equals this. This needs to be.
You need to receive two parameters: signature and compiler, right?
Signature and compile. No, it needs the module. No.
No, well, the module is already there in the compiler at the moment
No.
that we do have the tail call right there.
No, this needs to take a signature and a module.
But then again, we already have the module compiled in the compiler at that moment.
Which we have to look up.
Well, you can either I would do the lookup. So we need the module name. That's what you're saying.
I would put it outside of this function actually.
Oh, so you just make the module, the lookup of the module in the caller of this.
Yeah, like this function is just saying I have a module, I have a signature, I need to check if the module satisfies the signature and hide whatever the module has that the signature does not mention. That's the purpose of this function.
Compiled module. Compiled module is a module T, right?
Compiled module is a module T, yes.
So you're just gonna extract the environment out of the compiler on 52, and that's it.
No, I need to actually look up the right module.
Ooh, we have a problem.
But that's outside of ascribed signature.
Okay, so you're not gonna do in a single pass. You're gonna do in two passes.
What do you mean?
If you do a single fold, you can do the detection of the requirements of the signature and move things to the hidden field in the single pass.
That's not the same thing as looking up the correct module.
No, I agree with that, but that's why I am asking. So you're gonna do a two-pass process.
Okay, so we need a compiled module and we need a signature.
We already have the signature at this moment.
We need a compiled module and we need a signature and
Because I'm not disagreeing necessarily with you. I'm just trying to understand if we're gonna do one function from one functionality and another function for the other functionality.
I don't think I understand your question, Lemus.
Okay. So do you agree that we need to do two different kinds of processes at this moment? Down there, when we are doing the compilation of a module with an inline signature, do you agree there are two things that needs to be done?
Yes.
Okay. So my question is, what's the strategy to do those two things? I was considering doing a single function to do both. And given what you're saying and the arguments that this is going to take, my understanding is that this is going to do only a single thing, this function.
Which is?
Which is to check if the module is implementing the requirements that the signature is restricting, expressing, I guess.
No, it will do both, actually.
Oh, so it will do both. Okay, nice. So we agree on that. What are the arguments you're giving this guy? So signature, which we already have, and give a module, which is the environment of the compiler. So I was right. You were just past the environment.
No, no, this is not the environment of the compiler. This is the actual module.
Yeah, I think there's a confusion here. So if you go to the type of the compiler, how after you compile a module, you only get a compiler out of it, right? Do you agree on that?
You get a compiler, yes.
So in order to call the function up there, you need to get a compiled module as an argument. How are you going to give one? You only have one inside the compiler, right?
No, we're gonna do this. Although we do need the module name in this case.
We're going to do this.
We don't need the module name. Where is the module name?
564.
Match elements. It's inside of elements, isn't it?
Yeah, 100%.
That's kind of annoying.
Okay, so now I understand your plan. Your plan is that you're gonna actually um, no, I think I see your strategy. You're gonna do the lookup outside, so you're gonna get a compiled module from the environment of the compiler, which is a different module than the module you're looking for, and then you're gonna pass that to that guy.
Yeah, basically we just compiled the module. We're gonna look it up in the compiler environment, and then we're gonna pass that to the function, yes. That is exactly correct. It's kind of annoying that we have to do that though.
We should probably make a helper for that. But oh well.
Okay, this actually, no? And then this thing. Um,
Yeah, well, how do you make a comp time value? Can you go up?
this takes lookup module. This takes okay, let's look up there. Oh, it's this, okay. Although this is a terrible name.
I didn't have a better idea that time.
Hmm. Okay, why are we using the module name up there?
572.
Yeah, but this is the module name prime. Where is the actual... Oh yeah, we're doing this. We're doing this. Okay, so basically in this case here, um, if we get an OK, if we get an OK, we need to grab the lock content.
That's kind of funny that this is in the opposite order of what we usually do.
I mean, you can do it like this. Let um, compiler with uh, compiler with env equals. We're gonna have to get the env. Actually, we do have the env, no? But that's the old env.
Wait, old in comparison to what?
In comparison to this one.
Yeah, this one is the latest env.
Env with, and then hmm, ascribe signature. The signature is inline sig, and this is content. And we actually have to add a location here, don't we? Okay, what's the problem? Hmm. Modules, where is modules? Modules. Oh, right, we need to grab the modules from the env, don't we?
Wait, I was paying attention to something else. What's the problem?
Modules underscore as env.
What? Oh, okay, that makes more sense.
Hmm.
Wait, what are
Comp
you trying
time.
to do
Oh,
there?
oh, right. I actually also need to do um,
To do?
module here.
The types are not lining up though.
So this is a
Ah, you
signature
need
with
to.
location.
Yeah, and your function doesn't have location being used. You can either strip the location or let the location fly on the ascribe signature one. I think you should let the location fly because at least we can have errors on the ascribe signature one.
Yeah, let's do that actually. That's easier. I guess.
Is this enough? I'm not so sure. Here,
Not quite because.
you need to do the wrapper of the module.
Okay, so now what's the problem?
This expression has comp time. Oh, you cannot return a comp time with location for this. That's the problem.
That's kind of annoying.
Yeah, I agree. Just remove the location from the output of ascribe signature. No. Why?
There.
Why you rather do it like this instead of removing the location from the output of ascribe?
Because then I would have to grab the location from the place it comes from, wherever that is.
What? I'm
Like
confused.
I would have to grab the location from here and then add it back here, and it's better to just let it flow through, I guess.
Yeah, I'm not
You
understanding.
don't.
Ascribe signature is returning something with location. You can have the option of just not returning that. Does that make sense?
Oh yes, but then I have to add it back. You see?
I have to add it back. No, I don't see. You are purposely removing the location, right?
No, I'm not anymore.
Ah, okay, I'm reading this wrong. You're not stripping the location away. No, never mind, never mind. I'm stupid. I thought you were doing that. Yeah, it's probably in the body there. Yeah, this is also gonna fail because those things.
Okay, that compiles. Uh,
Okay, so now we have the module and we have the signature. Let's just fold over the signature, right? No, actually to do the process in a single pass, we rather fold the module, right?
we'd rather fold the module.
Yeah, because here's my strategy. You fold over the definitions of the module, and and then you do a lookup on the signature. If it's in there, then everything's rosy. If it's not, we have to remember to put this into the hidden, and we just continue, and we do this for all of the elements of the module. Does that make sense?
Yeah. Although I think I prefer to iterate over the signature regardless.
I don't follow. How are you gonna be able to do the double duty if you're iterating over the signature?
Because the accumulator doesn't have to be the signature.
Um, okay, but what's your plan on? Yeah, I still don't see how the folding over the signature is gonna solve it though. Regardless of the accumulator. What's your idea?
We have to iterate over every comp time declaration and every predicate in the signature. Um,
Yeah?
I guess we can do them one at a time. Let's say we do the predicates first because that's easier. For each predicate, we check that there's a matching definition on the module.
Yeah.
Um, I see. Yeah, because we need to hide everything else.
Yeah.
We need to hide everything
Well,
else.
your idea still works, but then you're gonna have to do some sort of set difference at the end. You see? Like, whatever you do at the end of iterating over the signature, you can see if it's you can do some set operations to make it happen. That's essentially what I'm trying to say.
Singleton is empty. Add, find first
I'm gonna use a
opt,
fold for
find
sure.
last. I'm checking if we have something equivalent to like select keys or whatever.
Oh, select keys. So let's assume that we do.
Iter map I. There's a fold. For all exists, add bindings, join.
Okay, I'm gonna try to look that up here on my end as well.
Split, merge, union. Filter map, partition.
Filter map should be it, no? Partition actually. Partition is also does the job. It reads returns a pair of maps where the first map contains all the bindings of S of the original map that satisfy the predicate P. So this is essentially a more noisy select keys, no? No?
Hmm.
Like we can make it do the job. It's just not gonna be as convenient as enclosure.
Okay, so partition.
In this case, you're gonna ignore the second argument, right? Because this is the value. We don't care about that. We only care about the keys.
Yeah, for predicates, we only care about the key.
Actually, this solves a problem for predicates, I mean, because this will give us two maps. Well, there is a cost because now we are doing whatever this does to split the maps up instead of doing in a single like linear. But I think this is going to be more readable actually, now that I think about it.
This is probably logarithmic.
Well, even if it is, I think it's more readable to do it this way.
Hmm. Okay, so basically the idea is we partition checking for presence in the signature, um, in the map of predicates that is inside of the signature.
Yeah,
And then we just have to check that they have the same size, and that should be it.
the same size, you mean? Yeah, actually, that's perfect. Because if they have the same name and the same arity, and we have the same amount, they are fulfilling the duty, right?
Yeah, this will get more complicated later when we add types, but for now that's sufficient.
Actually, I have a question about what's your opinion on that? Because
Hmm.
my understanding, and I'm getting this intuition from the way we're writing the compiler, it's there is a trade-off of doing multiple things in a single, like it's essentially the same principle that you wanted to do with Sal in the beginning, of having a single reader pass that does essentially everything. Of course, this goes into complications when you want to do some metaprogramming and things like that, but at the end of the day, at least for us right now, it would be okay to do it in a single pass, the type checking later, for example, because we're already going to have the perfect place to do it. And if you want to make it as a full separate pass, we're going to have to do a bunch of like boilerplate code essentially doing what we already did. If that makes sense. There's a reason to do that because that allows us to have like the compiler will fail faster because it's only doing type checking, which should be easier than doing the full compilation. But what do you think we're going to do when we reach type checking? Are we going to do a separate phase that precedes compilation and it's after preprocessor? Or are we just going to go to this function and do it in here?
Well, there are two answers to that question actually. The first answer is okay, if we're just doing a plain module that has no signature, we obviously can't do the type checking in here because we're not ascribing a signature, but we still have to do type checking anyways because there may
The
be
rest of the
type
program, right?
declarations inside of the module itself.
Yeah, exactly. Or the modules are being used in a way that we need to do some type inference, right?
Yeah. So in that case, it would probably make sense to check the types inside of the module compilation, actually.
Oh, so you would still do that mixed up. Like you would do the two things together.
Um, yes.
Okay.
But then the second answer is okay, what if you have a module that has an ascribed signature? Um, in that case, actually, you do need to do the type checking twice because you need to check that the types are consistent in the body of the module, and the module compilation pad is already handling that. But then you have to check that the types are also consistent with the signature.
I see what you're saying. Yeah, I I don't know. I think I am more in favor of doing it as a separate process because again, it should be easier to type check than to do the entire compilation process. It is just that I'm kind of lazy and I think, man, we already have all the pieces, like all the infrastructure to do it right now. So am I like, how expensive is this laziness of mine? That's kind of what I'm trying to get at. What's the problem?
I'm destructuring stuff.
Okay, let's do the partition function first. I think that's better.
Okay, so let's do predicates first because that's easier. So public predicates hidden predicates. Then we need to do
Bet map dot string partition, and now we need to make the predicate.
just for confirmation. The left hand side is the one that matches the predicate, right?
No, let me read here. The left hand side is yes. Yeah, the left hand
Okay.
side is the one that matches the predicate.
Okay, so we're gonna call this over the given module dot predicates.
Wait, but do you want to do it like this though? Ah, no, of course you do, because you're gonna do a lookup on the signature, and if it's true, the lookup, then it's public. Perfect. Makes complete
Yeah.
sense.
So this takes
Two
the
things,
key and the value. We don't care about the value.
not for predicates, no?
Actually, actually this is the wrong function.
Ah, yeah, that actually makes sense. Makes sense.
We don't care about the implementation.
Oops, no comma there. This is curried.
You just carried. Yeah, we don't care about the implementation. So we need to do.
Betmap dot find. Ooh, actually exists, right?
Not really.
Ah, this takes another predicate. Never mind. We need a find of sorts. Let me check here. That's terrible. There's no Boolean version. You need to do a find OPT.
There's no Boolean version. That's
Yeah,
very sad.
you can either find the element or and have exceptions, or you can or find the element with maybes. So I think you're gonna have to make it work with maybes. It's down there. Find OPT.
Okay, so find opt,
Pred name.
thread name.
And now you need to grab the signature predicates. So signature given signature dot predicates. And then you do a match on that. Option module OCaml. Actually, we may not have to use the maybe the match. We can either try to do a yeah isum. That works. I decided to use base instead of core or batteries, mostly because I already depend on ppx as expressions and added a dep on ppx compare. Wait. So when you say you decided to use bases, do you have all the things that you need, like the data structures and things like that? The main reason we suggested batteries is just because of the data structures. Anyway,
Mm,
so what's the problem there?
I just realized we don't know what kind of signature this is actually.
Oh yeah, actually I forgot about that. You need to actually match on the signature first, my man. Because if it's abstract, we need to explode phenomenally, probably.
Not really. The semantic is not quite that, but yeah, we do need to check that because
Are you sure? What are the semantics of trying to do an abstract signature?
like the point of an abstract signature is that okay, the module exists,
Oh, but everything is
um,
opaque.
but everything is opaque. Only the other things that are inside of this module that actually can see through the ascription have access to it.
Uh, okay, I guess the question is, do we need to change the behavior of the partition function depending on what type of signature it is? That's kind of the question. We have three types, right? We have abstract, plain, and module.
Yeah, and I don't think actually we can get away with doing this separately because we may need to do a recursive match. We may actually need to do a recursive match, which means this thing you need to be able to handle abstract signatures regardless. That's kind of annoying.
Okay, so could you repeat the last part? We need you to handle what? Signatures?
We need to handle all kinds of signatures here because
No, I agree with that.
this may need to do a recursive ascription is the issue.
No,
So
but
we can't get away.
no, I agree completely with that. That's not a problem. That means that you need to. The first thing you gotta do is to do a match on given signature, right?
Yeah, we do. We actually do. We actually freaking do. Match given signature with.
So it can be a plain signature, and it can be abstract and things like that. My immediate question is, uh, does the behavior changes from plain to abstract to module?
It does actually.
Okay, so if it's abstract, that means that everything is abstract and everything is gonna be hidden, right?
Yeah,
Okay. And what is the difference again between module signature and plain signature? Plain signature is the top level one.
it's the top level one.
Module signature, as far as I recall, is
It's a nested thing which is actually a
oh
signature,
exclusive
but
to modules.
it's a module. Yeah.
Yeah, so that doesn't matter for predicates. Yeah, okay, that's fine. We can continue doing what we're doing though. That's fine. What's the type problem now?
Mm. Oh yeah, this is actually a set. That means we can just do set find opt.
No, but in that case,
Actually,
maybe there's not. We don't need to do the find opt if that's the case. Let's try to see bet set. The answer is okay. It sucks, but at least it consistently sucks. Both the maps and the sets don't have it.
okay.
And here's something to piss people off. So you can use a flip function and get rid of the lambda. You're welcome.
And get rid of the lambda.
Yeah. If you put flip before the find OPT, you can remove the lambda.
Before the find opt. No, because we need to ignore this.
Ah, I didn't see that. There is another argument coming there. Well, there is a point-free way to do that, but it's not worth it. I'm not gonna pitch it. Anyway, so what's the problem now? This expression has type that, but an expression is expected of having type that. Ah, it's because it's predicate map.partition, not bet map.partition.
Okay, so this works. But now
Now what? Now we need to do the treatment for modules, right? Modules and signatures things.
well, yes, but before that, we need to check um, if this is a predicate map, right?
Yeah. Oh, you want to compare them, right?
If this equals bet set dot
Size, probably. Oh, wait. I was wrong. The bet set does have it. It's called mem. You don't need the option
okay.
with sum. Let me also see if I need to apologize for the map people as well. The answer is... Yep, I need to apologize for the map people as well. They also have for maps.
Man, this not equal sign is so goofy.
Goofy. Anyway, so if it's different, the public predicates from the given signature, we need to do a logger thing, right?
Yeah, this is an error. This is a completely an error.
Ooh, but there's a
Law.
problem.
What's the
Uh,
problem?
this, we don't have the complete locations informations to properly report this, because we're doing the lazy way, which is to just say, okay, the cardinality of the public predicates is different than the cardinality of the predicate. We don't know which one is missing. So there, we can put a to-do to address that.
What do you mean?
Exactly that. You don't know, given only the cardinality, which one is the guy missing. You're not going to be able to point in the error message to say, hey,
Of
this
course,
guy that the signature is saying you are missing.
of course we can. We can just grab the public predicates and do a set difference between this set, this key set, and this set here.
No. It's not about we can or we cannot. I'm just saying that right now in the code doesn't have it. Instead of putting effort into that, I was just proposing to put it to do. But you can do it right now. That's fine.
Okay. Okay. What's
Put the siglock in here.
the siglock? Why the
Yeah,
siglock?
it's the location of the signature. Um, and this is just for the purposes of having a location for right now. Put an error message here, so mismatch between signature and module or something like that. We should also say uh, which module, right? Because this is gonna point to the signature. So we should probably also make an error message for using the module location. What do you think?
Mm, in that case,
Because remember, this function is going to be used for both anonymous and nominal signatures, right?
and named signatures, yes.
Okay, so you rather. Okay, so you rather just do the one message. Yeah, that's perfect. 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 Okay, now put a to do, right? So we can list which predicates are missing. It may be more than one though. That's why I don't want to just use like. We're gonna use the set difference of 100%, but anyway. Uh, okay, now we need to do the module stuff, right?
Right. Actually, yeah, right, we do. So we
So
have to do basically the same thing here, except the module case is a bit trickier because it is recursive.
in the sense that we may call ourselves ascribe signature, right?
Yeah.
Okay. Um you have a plain signature. Uh, yeah, it's the same thing, right? Instead of doing given signature dot predicates, you're gonna do given signature dot modules,
Well,
and you get.
yes, but as I said, this is recursive in that case.
No, yes, yes, I agree, but I would just copy paste the same structure that we have for predicates right now.
This is not called modules, is it?
It should be.
It is.
Should be.
Oh, it's because the given module actually, I think it's called. Well, no, it is modules
It is
actually.
modules, man.
Ah, it's because of this. This is not a set. This
Yeah.
is actually a map.
Yeah, then we need to do the bat map.string.mem or something like that. What is the predicate name type?
Oh, actually, this should be called um, comp time name.
What's the type? Oh, this is the type predicate name, which means this is a functor. Okay. It is not batmap.string then. It's just batmap.mem. Okay, what's the problem now? This
No, this
is.
is a string map. No, this is a string map.
Wait. Why is this? Because the names are unique. Makes sense. No, okay, so put the batmap.string back, but we need to do a dot on the comp time name. We need to grab only the name. Put dot after this.
But this is not supposed to be a predicate name.
Oh, okay, I see what you're saying.
Yeah, see?
Okay, so what the fuck is going on over there? Like, this is not a LSP joking. The compiler is also complaining the same thing. It's 330. That's the problem. Thank you. Thank you very much. Thank you very much. This in 329, this should be public comp times, not public modules, because this is also handling signatures for us as well. Cool. So now we need to do the if, but recursively call ourselves, right?
Mm, yeah. Hmm. Hmm.
Yeah, yeah. You're gonna have to compose that a little. Yeah, yeah. But hidden needs to be composed out of the two hiddens, right? Yep. That should be it. Oh, none. I forgot. I forgot. What's the problem? Oh, you're missing location. This entire thing that you wrote is content. You also need to grab the location. Look at line 311. Add location. Which location are you gonna give this one? Module lock? Cool. Okay, but where is the recursion, Maria? I thought you said we would have to recur ourselves. Which makes sense, right? Because you may have another signature inside a signature.
We do, and we also have to do this again.
Not modules, comp times. That's also no, no. The problem is that's also a problem. But this is not a set. Exactly. Okay, but where are we calling ourselves? Where would we do that?
Hmm.
Some modules are signatures. And put on 339 signatures as well. Thank you.
Right, but then we still have to do the recursion here. So here's the thing. We need to
Wait, we're gonna do in the body of the if, the recursion?
not in the body of the if, it's after the if.
Oh,
But
after.
yeah, here's the thing. This recursion is not uniform because we have to treat different comp time values in different ways. Like for instance, if I have say a signature in the inside of the module, and there's a signature declaration in the signature, then that's one behavior. If there's a module inside of the module and there's a module declaration in the signature, we have to do a recursive match in that case.
Just remind me again, we need to do this recursion because inside a plain signature, you may have more signatures inside of it.
Yeah, you may have a
And
you may have a declaration of a module inside of the plain signature, right? Module sig.
yeah, no,
And
that
that
makes sense to
means
me.
there must be a corresponding nested module inside of the module that we're checking.
Yes, yes. That sounds annoying.
It is kind of annoying.
It sounds
Hmm.
annoying. So let me see if I understand. What we did so far are only the top level ones. top level predicates, which in this case cannot be they're not nestable, so that's fine. But the directives are nestable. And what you're telling me is that we need to go deeper.
We must go deeper.
Isn't it a matter of just peeling off layers of the modules and signatures and recurse ourselves?
It is. It's just, as I said, the recursion is not quite uniform, which is annoying.
No, but it seems to be. Okay, could you explain again why it's not uniform, please?
Because, like, if you have a signature inside of the module, right?
Yeah.
Then that means there must be a corresponding signature declaration nested in the signature. But if you have a module nested inside of the module, then there must be a module declaration in the signature, and you have to match those recursively.
The second case I understood, the first one I didn't. Sorry, could you repeat the final time?
Okay, let's say you have a signature,
Yeah.
and part of the signature body says, okay, there must be a signature with name, let's just say T or whatever.
Yeah.
Then you have to check the module if there is actually something not named T, which is a signature.
But I don't understand that because in a module implementation, you wouldn't have a signature there, right?
I mean, you could.
Oh, you can. Okay, I didn't know that. So you can have a signature inside of a module implementation.
Yes, you can.
Oh.
Like you could say, like inside of B, you could say that there's a signature.
Well, but in this case, the signature is going to be local to this module. That's what you're saying. That's what would this mean?
Yes, signature whatever. And then let's say that to satisfy the signature.
No, no, no. I think I got it. I just didn't. I never thought of using this case in OCaml. That's why it was unnatural to me. No, but you are completely right. You're completely right, as always. Almost always.
Yeah, let's say you must have a signature alpha. Then, if you want to match a signature to this module B, the signature will have to look something like this, right? Signature sig of B. Oops. I can't type tonight. Like, you would have to have something like, I don't know, signature whatever, right? Something like this.
I see. Okay, I didn't know. I never thought of that. That makes sense to me. What does this mean? This means that. Ah, man, that's so annoying. Right? That's very annoying.
It is, actually.
Okay, so what's your plan on getting around the annoyance?
Hmm. What's my plan? Well, the nested case for the if you have a nested module, I think there's a trick we can do actually. Let me go to the here. Mm, yeah, so we have a module signature here, right? In that case, actually, what are we doing here?
No, this is the This is the same thing, but instead of having the compiled signature, we have the module T, and the types are different, right? The types are different.
Mm,
Wait, but they didn't have to be different. Now that I'm looking at it, compiled signature on line 31 is just a module T, but with the comp time entity being signature, which is already the case on line 39 anyway. So this seems unnecessary. Do you agree?
mm,
Ah, no, it is not the same. Because in the case, wait, yeah, it's not the same. Because in the case of module signature, we are ignoring the predicates, right?
Only the definitions.
Only the definitions. But in the plain signature, we are not, because we are using predicate name on 33.
No, but this is a set, you see, not a map.
Ah, okay, I didn't notice that. We are also using different data structures for each case.
I wonder if we actually need to do this though.
Which part?
Like, do we actually lose anything? Because we just added this, right? This didn't exist before.
Yeah.
Do we actually lose anything if we do this?
Um, I don't think so. At least at first glance.
That would probably break a bunch of stuff though.
Oh, it will. But that's kind of expected if you think about it. Compile module signature. Yeah, the type of ascribed signature to module is now incorrect. This should be compiled signature instead of module T. Module T doesn't need to be a. Oh, we'll maybe be using many other places. That's why that's there. Compiled signature uses a set.
This is just identity now, no?
Yeah, good call. This is identity now. So 137.
Yeah, we don't need this.
Man, but that seems a little bit suspicious. There was a reason to do that, wasn't it? We're not crazy. What was the reason?
Hmm.
Aside from, oh, we use sets instead of a map, and sets are simpler. I don't think that we would use that such a reason. Especially because we were doing module T with unit, so we wanted a set for this for starters. Like, what are we doing? What was the reason to do this? What is the difference between a plain signature and a module signature? Are we treating them differently?
We are. A plain signature is what you get when you
No, 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 no,
do.
no. I know the use cases for in the Karuta code, but I'm talking in the implementation of the compiler.
Uh, well, other than the tag here, we were using that function to convert the types, but they are isomorphic, so there's no extra information there, right?
No, but are we treating them differently? Are we doing a function call in one that we're not doing in the other?
No, we weren't.
Okay, but then
The,
this is unnecessary.
well, we do need a separate tag because there's a difference between. Let's go back here. There's a difference between doing this and doing this. Module C. Right? So you need to be able to tell these two apart.
Okay, so we are treating them different in the compiler because this module signature is a module inside a signature, and plain signature is a signature inside a signature.
Or it could be just a signature inside of a module as well.
Yeah, sure, sure. Okay, so we do need the tag. That sounds a little bit sad because it's essentially the same data, but the tag matters. Okay, doesn't matter. Okay, this means, are we using module T anywhere aside from up there?
Nope.
Okay, so we can kill the synonym now, right? The alias.
We can.
Awesome. Let's do that. Just make this definition of the compiled module be that, and there we go. So it's gonna be comp
Comp
time on
time
38,
8 is going to be comp time.
and the multi-declaration is gonna be the predicate definition. Awesome.
And it needs to be.
Compiled module option. Don't remove the remove no line 40. There's still a deletion there. Awesome. Simplifying the types. Who would have guessed? Okay. Cool. So now we did this. Oh, because we were doing the ascribe signature. So we need to call ourselves essentially.
Actually, we can do a slight improvement here. But this can't be inline, can it?
Well, let's try. I'm actually search for that. You can only inline records if you're using an EDT, unfortunately.
Yeah, this kind of sucks.
Okay, but what's the difference between them?
The difference is now there's no hidden inside of this.
Okay, I don't know if that was worth it. I was expecting more, but okay. Uh, okay, now we need to recurse, right?
Yes, we do, in fact.
Okay, and now we need to do the differentiations between the cases, right?
We do indeed. Yeah, because we actually need to. Hmm. We need to.
We need to call ourselves passing public comp time as
No, we
the
actually need to iterate over the keys, the key value pairs in public comp time, because we only need to call ourselves recursively if we have a module in public comp times.
okay.
Uh,
That sounds good. That sounds like the plan.
yeah, and if we have signatures on one side, well, we have. Hmm. Oh man, we're gonna have to deal with abstract signatures at this point, won't we?
Well, but this is already in the to-do on 347 anyway.
I guess we can do something like. Yeah, so batch map dot.
I guess this is the cost of non-uniform recursions, right?
The problem is not that the recursion is known. Well,
It's part of the problem. It's part of the annoyance. Come on.
the problem is that the type is uniform, but the
The situations that we have to handle, they are not.
the recursion scheme isn't. Yeah.
Yeah, that sucks. Sucks. Okay, the fold probably takes a key value, right? Key value. Let me find the fold. Yeah, so the value... Actually, that's not correct. Fold only iterates over the values.
Can't you just do a map here?
Also no, because a map on a bet map does also over the values. We need a special map or fold. Let me find it.
Map I.
Map I is for iterating with like numbers and things.
No,
Oh,
bat map, map I.
they're using map I for the key as well. That's such a
Well, it's
bad
for
name.
well, it's for the index, no? The index is a key in the case of a map.
Yeah, but usually, well, not usually. In, for example, F sharp, map I is always an integer. But I guess OCaml came first, so who cares?
Well, a map is not really indexed by an integer, so to be fair, it could be because this is based on an ordered key type, but it isn't for some reason.
Yeah, but I would just say like map underscore key or something. Map underscore with key. I don't know, something like that.
Mm,
Yeah, it's the key first. So it's gonna be a string and a comp time with location.
this has location.
Yeah, just do dot content. Just do dot content. It's fine. Of course. No. The
Ah,
bat
no, the
map.
location is nested,
Yeah,
yeah.
it's inside. That's fine. So list map by does exist, but also map.map exists, and it takes. Well, no, that's awesome, Ace. That's perfectly fine. It's just because in OCaml, if you only use map, well, OCaml no, batteries. If you use only map, you're mapping over the values. You're like you don't have the keys in the lambda. That's kind of the point. You have to use map I in batteries to have access to the key as well. And I have a biased brain in terms of that because the first time I found map I was in F sharp, and in F sharp I stands for integer as far as I understand. But Marinho is kind of right. If you have a generic map, map I doesn't make sense. Exactly, it's map I for key value mapping instead of I don't know map with key or something like that. Weird. Yeah, or just map, right? And then they could do a map vals later if you really want to don't have the keys in the lambda. Okay, what do we need to do now? Marinho.
Now we need to do the fun part.
So
See,
batmap.string.
You get it, the fun parts, because it's inside of a fun.
Yeah, no, I got it. Uncle joke, dad joke, all combined. Bad batmap.string.findopt. You pass the key, which is k in this case.
Actually, I can just do find here, no?
That's gonna explode if it doesn't find.
But public comp times was constructed by checking the keys inside of the signature.
No, no, no. Yeah, this should be unreachable, but we don't have X. We're gonna have to do a try catch to properly log this as unreachable with our logging system.
No. The point is, like, this is actually unreachable because of how public comp times is constructed.
No, I understand what you're saying, but we should not do it with that assumption, because if somebody in the future does maintenance in the upper part of the code, the types won't break down here, informing the person necessarily. But if you have an unreachable in the logger, then we at least gonna have a nice way of reporting that.
Ah, okay.
Like you always have to think of somebody new reaching to the code and messing around without having the full context, and then he's gonna do something that's gonna break the invariant that we cannot enforce via the types.
Hmm.
Yeah, so none should be unreachable, like simply unreachable. And exit one on this one. And the message should be, I don't know, invariant broke is broken, something something, I don't know, whatever is more descriptive.
Hmm.
Yeah, and then we can go proceed with the sum. This is a nested, not necessarily a nested sig. This can be a nested comp time, right? And this is failing because ascribed signature is non-recursive.
No, this is a signature.
This is a signature. But how do you know that? Well, aside from the
Because
semantics, right? This
because of the
doesn't
type.
guarantee. Oh, this type. Okay. No, never mind then. Okay, but now that we have this, ah, V, what is the type of V? Compiled module. That's incorrect. So the type of the map_i and the public comp times is not matching, right? Because public comp times has a bunch of comp times, but the ascribe signature is forcing the type of V to be something else. That's the problem.
Ah, right. We actually have to match V here.
Yeah.
Um.
Ooh, which name are you gonna put that one? Okay. That's cool. Uh, this expression. Oh, you need the location back in.
Ah,
Yeah, the nested module is missing location. That's the problem. Add
it's missing the
location to it.
location.
Yeah, you need to add. Wait. Ooh,
Hmm.
we don't have a location of nested modules. That's a
Maybe
problem.
we should. Maybe we should.
That's a phenomenal problem. Yeah, but I think that's gonna break shit all around. Because the entire compiler is assuming that's not true. What a why? Oh, I know why. It's because the AST has the location, but we got rid of it when compiling to this intermediate representation. Ah, fuck. Ah, no, it's not
Hmm.
because of that. It's because the locations on this level don't matter. They are embedded in line 41 and 42. Because multi-declaration have locations, and the modules have locations in their alongside the comp time. This comp time on 46 shouldn't have location, but now we are kind of forcing it to have, in a way. Okay, we have an option of removing the location from the from the arguments, right? We have that option.
This is a map of comp time with location.
Oh, but this is the shadowing, right?
Compiled module. Compiled module. Yeah, this is wrong actually.
Yeah, but this is because we haven't finished the map I. That's why it's wrong.
Hmm.
No, 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 no. Public comp times needs to be a compiled module.
Needs to be a compile. What do you mean?
Line 351. What's the output of a scribe signature? This is the entire problem. It's because this function returns compiled module, and that's mismatching with the comp time up there.
Uh, there. So what's the problem here? Wait, V doesn't have location. It should have. This is comp time with location. This is comp time with location, which means this should be a comp time with location, no? Surely this should be the case.
Yeah, this should be the case, I agree.
Okay. And then for the case where we have a signature on the right hand side, um,
Then it depends on the kind of the signature, right? Or something like that.
Yeah, if the one on the left is a plain signature, then they must be equal. If the one on the left is abstract, then we need to make the one on the right abstract. If the one on the left is a module signature, that's an error, actually.
Let's do the errors first then. Do pattern matching on this one for the module case. So this is an error. What else is an error?
And this is the... Yeah, those are the three cases. So, yeah, this case is an error, actually. Logger error. We need to give the... And here is exit one.
Yeah, it's probably going to be v location, no? v.lock. So let me see if I am understanding what the fuck is going on. So this means that we are... Given definition is a signature, but it was supposed to be a module.
Now we need the...
Need the...
We're doing a find opt here. This doesn't return location, does it?
Look at the type of nested sig. It does.
It does, okay. Um,
So which case is this one though?
okay, this is the case where the signature on the left...
What is
Actually,
left and right in this case? What are you calling left and right?
okay, the one on the left is the signature and the one on the right is the module, okay?
Okay.
So on the left, we have a signature here, right? The nested signature. Actually, we need to match it as well.
Oh really?
O'Reilly, yes.
Oh, this is okay. Now I understand. You need to match this one because you are matching the top level with and the one on the V is the inner one. No, the V one is the one on the module side of things, and the one
Yeah,
on 347 is the one on the signature side of things.
yes.
Makes perfect sense. So if you are a signature, V is the module. So you have a signature in the module, and inside that you have a module signature. Yeah, this complete doesn't make sense. This should be an error. Awesome. Right?
Mm,
Assuming the nested sig is a plain signature, of course.
okay, let me think for a second. Inside of a module, directly inside of a module, actually, I think we're missing an invariant in our types.
Which invariant?
Like a module is a compiled module, right?
Yeah.
Which has modules, which is a map of comp time with location,
Which is recursive.
which is recursive, but comp time can be a signature, which can be a module signature,
Which is also recursive.
which is also recursive. Yeah, we actually shouldn't have a module signature inside of a module at all. Like that should be impossible.
Ah, I see. The type Tetris in this case is allowing the situation to be representable.
Yeah.
All right, so this means that we have a problem. How do we fix this? Because it's highly mutually recursive.
Mm, I think you can get away with this. But it's gonna break stuff.
Oh, this is gonna break many things, because you are removing the ability to immediately pattern match on the comp time. That's gonna suck ass, man. Are you sure about that?
Am I really?
Yeah, because now on 46, if you have a signature, you cannot immediately know what type of signature it is.
Of course I do. It must be a plain signature in this case.
No, but this is not. How do you know that, actually, first of all?
Because comp time can only happen inside of a module, right?
Uh-huh.
Um, inside of a signature, you can have other plain signatures. You can have abstract signatures, but you can have a module signature, which is a module declaration inside of a signature.
Uh-huh.
But that's also a compiled signature, you see.
Wait, I'm tired and hungry. Could you repeat that?
Like, okay, comp time can only ever happen inside of a module, right?
Yes.
That means that whatever constraints are defined here must be the constraints that we require inside of the module body, right?
Yes.
So what can you put inside of a module body? You can have a compiled module which has modules and predicates,
Yeah, you can
right?
have more modules. That makes sense.
Or you can have a signature, and in this case it must be a plain signature. So this case, see?
Yeah. Oh God. Okay, so let's address the two. Okay, given that this is gonna break shit all over the place, uh, on line 32, let's address this to do as well. It's kind of bothering
Line
me.
32.
Yeah. So is it enough to just have a string here to differentiate abstract signatures?
I mean, we could use a string, but it's probably better to just use an integer actually.
What do you mean?
Because we will need to generate fresh values for this thing every time we have a new one.
Fresh values to this thing every time I have a new one.
Yeah, like
Why
if we do,
that's not why a name is not enough? That's my question.
because if I do like C of B, we have a signature whatever, which is abstract. We have a signature whatever 2, which is also abstract.
Yeah.
Those have to be different, and they do have different names. But if we have on signature other, this whatever must be different from this whatever.
Ah, and signatures are not buckets, so you cannot just namespace them.
Yeah.
Fuck me. Okay. I guess I have to concede. Let's put an integer there. Uh, it's so funny how we do a bunch of development and everything is fine, and then a single particular feature uncovers a problem that was not yet a problem until then in the types. That is so cool and kind of annoying because this means that in the future we can discover again that we were wrong and then more refactoring needs to happen. This is gonna break the shit out of the compiler, man. So what is this? This needs to return something that I don't know what it is. What's the type of other? Ah, I couldn't read, but okay.
Undefined or unexpected signature.
Undefined. Whoa, that seems bad. Like the tags are mismatching in the polymorphic variants there.
Oh, yes.
Yeah, that seems very terrible. Ah, it's an unexpected signature. One of them is expecting compile. Okay, so probably the output is compiled signature, but the type is just signature as it is, plain.
Yeah, we need to look up mod sig.
Yeah, it's lookup mod sig the problem. This needs to return compiled signature instead of signature. And this should solve most of it, I imagine. 227. So, we need to not return that. What's the type of signature in 223? Oh. Okay, can we turn one of these into compiled signature?
No, we can't. Because this
Wow.
could be abstract, you see?
This could be abstract. Now what? And now other things are breaking. Oh,
Hmm.
you can remove the plain signature in 201. That's the problem. No. It was. I think it was correct what you did there. 201. Just remove the plain signature constructor.
One moment.
Yeah, this fixed down here. Changing the type fixed the error down there in 281. I think you got it though. I think that was it. You just need to remove the extra wrappers that you were putting before. Because now this is a compiled signature, which means that this doesn't need a constructor there. Which also means the same here, probably. What's the
Yeah,
type
this
of
is.
signature?
Yeah, no, the problem is that this is actually a signature.
Oh,
Yeah.
this is one. Can we... Okay, but you said you cannot lift a signature to a compiled signature, right?
No, you can't, because a signature can be a plain signature, which is the natural lift. Like a signature is actually, it embeds a compiled signature as a plain signature, basically. But there are the other two tags, which we would have to, well, handle, but we can't.
No, but this is a problem, because if we cannot lift one to the other, what do we do here?
Mm,
I'm gonna finish the recording right now.